A 2100 continuous flow geyser has water inlet temperature 10 degrees Celsius while the water flows out at the rate of 20 grams per second. The outlet temperature must be dash degree Celsius. So here I have drawn a picture of the geyser. Maybe it might be the geyser, might not be, but this is how it works. The water comes in at 10 degrees Celsius. The water's temperature is 10 degrees Celsius and the geyser is 2100 watts. I'll explain it later what it means, and it kind of heats up somehow and it comes out at some temperature which we have to find out, right? Okay, so we have to calculate that that temperature. Now 2100 watts is the same thing as 2100 joules per second. That is the definition of power. Of the watts is the unit of power, right? It is joules per second, or the rate of work done, or whatever you call it, but its units is joules per second. Okay, so if I talk about the 1 second of the journey that the water accomplishes in this geyser, then in this 1 second, how much water is going to go in this geyser and come out? 20 gram of 20 gram of water is going to go in and come out in 1 second, right? That is what is meant by rate of water flowing out, right? So in 1 second 20 grams of water is coming in and coming out, and there is a transfer of 2100 joules of energy in 1 second, and that is because the rate at which the geyser flows out its power is 2100 joules in 1 second. So if we talk about 1 second, then it'll develop 2100 joules of energy, right? Okay, so what will happen in this 1 second? Well, this is the mass of the water and this is the heat supplied to the water. Now energy and heat are almost the same thing. Okay, so you can kind of view this as the heat supplied, 2100 joules of energy in 1 second. Okay, so that's not a lowercase q, but that's fine. Yeah, so the heat added to the system is ms delta T, right? So where q is the heat, m is the mass, s is the specific heat, and delta T is the temperature change. Okay, so what is q? Q is 2100. What is m? It is 20 grams times the specific heat of water in calories is 1 calorie per gram times the temperature change. Well, the initially the water was at 10 degrees Celsius, right? And if I assume that it'll come out at some T, and which will be higher than 10, so the temperature change will be T minus 10, right? Okay, so now what we'll do, let me scroll down. Okay, so grams goes away and this is in degrees Celsius. Okay, and this is in joules. Now 1 joule is actually 1 calorie. 1 calorie is defined as 4.18 joules. Okay, so what will be how much will be 2100 joules of joules will be how much calories? Well, it will be 1 divided by 2100 divided by 4.18, right? So I'll plug it in here. 2100 by 4.18, and that is in calories. Okay, and that must be equal to 20 times 1, which is nothing, times T minus 10 degrees Celsius. And if you do a little bit of calculations here, you will find out that T comes out to be 35 degrees Celsius. Okay, so that is the temperature at which the water comes out, and we got that from this expression that Q is ms, where Q is the heat, Q is ms delta T. Okay, so that was a question of almost calorimetry, and not too much, but yeah, it was kind of practical. So I'll see you in the next video.